All right, today we're in section 6.2, writing and solving proportions. Today we're going to learn two methods. There's three methods to solve a proportion. Today we're going to learn two. Raise your hand if there is, from Trinity to your house, if there is more than one way that you could get from Trinity to your house. Is there more than one way? Yeah, of course, right? Okay. Sometimes, maybe from Trinity to your house, is there like a scenic route that you could take that's maybe a little nicer, but maybe longer? Anybody's parents, do your parents sometimes, do they say, oh, let's go, this way because there's a lot of pretty houses or this or that? Anybody's parents like to take the scenic route sometimes? My mom did that on the way to St. Augustine one time, and it took us 2 hours to get 45 minutes. Yeah. Okay, how many of you, though, instead of going the scenic route, you're like, man, I just want to get there. Just get me there as fast as possible. That's the way I want to do it. Okay? Well, with proportions, okay, so stay with me. With proportions, it's very similar to that. There are several different ways to solve a proportion, but by the end of the lesson tomorrow, you're going to be like, why would anybody solve it that way when you can solve it this way and it's so much easier and faster? Okay? Now, the downside is I've got to teach you all three ways. Okay? You do have to know how to do all three ways, especially for your homework, because it says solve it using this specific method. You've got to know. The good news is on your midterm, you can choose whichever method you want, and you can use that method. And I could probably guess which method you're going to choose. Okay? So, the first method we're going to learn... Oh, sorry, real quick, I just need to include this in the video. I know you already have it written down. But a proportion is an equation that shows that two ratios are equivalent. Remember, ratio is a fraction, so the proportion is the entire equation. And I don't like hearing you talking. You need to stop talking right now. Okay? All right, so a proportion is the entire equation. So here's how it looks with equivalent ratios. Instead of writing down this entire definition, I want you to write equivalent ratios and then write missing link. Missing link. So tomorrow when I ask you which method of solving proportions uses a missing link, you're going to say equivalent ratios. That's it. Equivalent ratios uses a missing link to solve for the unknown part of the proportion. Okay, so here's what it looks like in a proportion. I've got these proportions here. All right, and here's what I look for. I look for the side of the proportion, top or bottom, that has both numbers. So it does not have the variable, 6 and 18. Okay, and I look at these numbers and I ask myself, okay, how do I get from 6 to 18? What is the missing link? 3. So I write a 3 in parentheses in between those two ratios. That's my missing link. So 6 times 3 is 18, and it works the other way. 18 divided by 3 equals 6. You have to pay attention to which way the numbers are trending. Are they trending up? Okay, we're multiplying. Are they trending down? Then we're dividing. So since we're going 6 to 18, we know we're multiplying. Whatever we do to bottom, we do to top. So what is 5 times 3? 15. X equals 15, and that's it. So your work is to fill in the missing link. Your answer, X equals 15. On the second one, I want you now to fill in the missing link and try to tell me what X equals. So what is the missing link? No. What's the missing link? 5. So I go 7 times 5 is 35, so 4 times 5 is 20. X equals 20. Who got it right? Okay, very good. What's my missing link for the last one? 9. And so, again, 8 times 9 is 72. So 3 times 9 is 27. Who got that one right? Equivalent ratios. All right, now we are going to do a couple more practice ones because now these are going to look just a little different. Now, the first two, yes, but look at the third one. Look where the variable is. Now it's in the first ratio. But look, once you fill in your missing link, look at which way the numbers are trending. Now they're trending down. So what would x equal? Now you're not multiplying, you might be dividing. All right, now pay attention to which way the numbers are trending. Try to solve all 4 of these. What's the missing link for the first one? 7 to 21. What is it? What's the missing link? 3. Very good. So 2 times 3 is 6. Very good. What's the missing link for the second one? 4. So 3 times 4 is 12. What's the missing link for the third one? 5. Now watch though. Now I'm going backwards. 10 divided by 5 is 2. So 20 divided by 5 is 4. But now look, just because the variable's in the first ratio doesn't mean it's dividing. What's the missing link for the last one? 4. You have to look at how the numbers are trending. How do you get from 12 to 48? You multiply. So you still multiply, even though it's in the first ratio. You have to look at how the numbers are trending. They're still trending up. I still multiply. All right, so that's the first method. The second method you actually have already learned, except now we're just putting a different spin on it. It's solving using algebra. Now, whatever number is in my denominator of the ratio that I do not know the value of the numerator, I'm going to multiply both sides by that number to get x by itself. So, multiply both sides by 12. Can I cross-reduce anything? Yes. On the other side, 8 and 12?
8 and 12, 4.
So now, 2 times 3 is 6 over 2, which is 3. X equals 3. Okay, so we solve using algebra. What would I multiply both sides by for the second one? What number?
9.
No.
36.
Whatever number is in my denominator that's connected to the variable. Now, let me point out also, algebra, are you listening? Algebra only works if the variable is in the numerator. If it's in the denominator, I can't use this method. Equivalent ratios, let me throw out a proportion to you. 1/3 and 6/10. Let me ask you this. Is there a defined missing link here to go from 3 to 10? So, no, it would be like 3.1 or 3.3 something. All right, now listen. Listen. So the equivalent ratios only works when there's a defined and whole missing link. Well, sometimes there's not. How do you get from 8 to 20? It's not a clear number. So that's why these two methods are not going to be the preferred method, but you still need to learn them. All right, multiply both sides by the reciprocal on the second one and solve. What do I multiply both sides by?
36 over 1.
36 over 1, both sides. So it cross reduces. Did you get 27?
Yes.
Raise your hand if you got 27. That's not enough. Okay, we're going to keep practicing until you get them all. Let's see who can get the third one. What is connected to my variable? That's what I multiply both sides by. Multiply both sides by. What did I? 84. That's what's in the denominator. Can I cross reduce? Did you get 48?
Yes.
All right, raise your hand if you got 48.
Yes.
Any questions? Any questions, guys? You feel like you get it? You have a whole section of this on your homework tonight. Okay, last example. Okay, so last example, we're setting up a proportion. I feel like these charts are a little confusing, so I'm going to go straight to the example. All right, it says each day, read the example with me to yourself as I'm reading it. Hayden, this is where the example is on the screen, please. Each day, an elephant eats 5 pounds of food for every 100 pounds of its body weight. Write and solve a proportion to determine how much food an elephant that weighs 9,300 pounds eats per day. All right, so a proportion involves an equal sign, yes, and a proportion involves two ratios. So here's my fraction bars. So here's what I have to make sure that I do. In my numerators, I have to compare the same unit. So I could put in my first ratio 5 pounds of food for every 100 pounds of weight equals, do I know how much food an elephant that weighs 9,300 pounds eats?
Yes.
No, I don't. X is what I don't know. And he weighs 9,300 pounds. I have now set up my proportion because I'm comparing in my numerators, I'm comparing food to food, and in my denominators, I'm comparing weight to weight. Now let me ask you this. Could I do weight in the numerators and food in the denominators? Yes, I could. As long as I'm comparing the same unit, guys, I could flip it around and I would still get the same answer. So there are multiple ways to set up a proportion. This is the way that I prefer. This is the way that I prefer. Just kind of setting it up as I'm reading it. Okay, so now we can solve the proportion. Now, what do you think? You want to use algebra?
Yes.
I mean, you could. Okay. What about equivalent rates? Is there a clear connection? Yeah, there is. How do I get from 100 to 9,300? 93 is my missing link. So if it's missing link on the bottom, it's missing link on the top. And 5 times 93 is?
465.
465. And make sure you label pounds of food. That's a lot of food. Don't you wish you could eat that much and not gain any weight? I don't know. I mean, that would take us like a week to eat that much. Not more than that. Oh my gosh. That would probably... How long do you think it would take you to eat that much food? Like a year? I don't know if we even eat that much food in a year. Think about it.
A day for me. I'll take a year.
Okay, maybe we eat like 2 pounds of food a day.
No.
I wonder how much food we eat, like pound-wise. That's something to think about. All right, I want you to solve one. Set up this proportion. It's just different numbers. Different numbers. Actually, I'm going to change this. I'm going to say 3. Whoops. Hold on. Hold on. Sorry, hold on. All right, I'm going to make this 3 pounds of food. All right, now set up the proportion. An elephant eats 3 pounds of food for every 100 pounds of its body weight. Write and solve a proportion to determine how much food they eat if they weigh 1,500 pounds. By the way, that's like a baby elephant. That's a really light one. Elephants are super heavy. All right, someone raise your hand and tell me, how did you set it up? How did you set it up, Samantha?
3 over 100
Yeah, equals x over 1,500. Again, because in my numerators, I compared food and food, and denominator compared weight and weight. Okay, so now which method did you use? Equivalent ratios? Probably. What was my missing link? 15? Did you do algebra?
Yes, it was much easier.
I don't. Multiply both sides by 1,500? That sounds like a little more work. What is 3 times 15?
45.
X equals 45 pounds of food. Okay, so on your homework tonight, on these where you set up your own proportion, you're going to be checked on, did you set up a correct proportion, and then did you get the right answer? Okay, if you understand that, that's everything you need to know for 6.2. One more lesson, and then that's it. It's midterms. One more lesson.